So 3.2 warm-up starts off. It says, what is the converse of the statement? If AB equals 8 centimeters and CD equals 10 centimeters, then AB is less than, or the length of AB is less than the length of CD. That's what those AB and CD means without those little bars on top. So we're going to start off by switching it around. This part here has to start first with if AB is less than CD. So far, looking at my answer choices, that looks like it's going to be A, and then you look at the rest of it and it says then, and then it's this part of it. So you're just switching the statements that come after the word if and the statement that comes after the word then. Those switch spots for a converse. Okay, pretty straightforward, hopefully. Number 2, which of the following is a counterexample to the statement below? So we have to make sure the beginning part stays true. So you want to keep AB equals BC true, and then look for whichever does not show that B is the midpoint of segment AC. So if I look at the first one, this right here shows AB and BC are equal to each other. But then if we keep going on to see that B is the midpoint of segment AC, actually I'm sorry. Yeah, we want to see that B is not the midpoint of segment AC because this is actually a true example. This works. AB is equal to BC and B is a midpoint of segment AC. So we don't want to use that as a counterexample. Now for letter B, AB and BC do not equal one another because notice the little tick marks, and you can tell by the diagram this little section here is so much tinier than B and C, so B can't be correct either. And that leaves us with C, and the reason for that is because it's showing that AB and BC are equal, but it is not a midpoint because of the way the diagram is drawn. You can't have a midpoint if it's not a straight line, since BC is going up like this. Okay, so the correct answer there was C. So on to 3.2 notes. It says reasoning using properties from algebra. So it's going to bring back a lot of those properties that, like things that you've always done when you're solving an equation and not realizing that it was an actual property that you were using. And so we're going to give it a name of what property it was. And when we get to these things called proofs, or like how you're reasoning through it, we are going to need to write these properties as our reasons. Okay, so first a couple of quick vocabulary. The first one is what this new unit is about, proofs. So proofs are basically a logical argument that show a statement is true. Now you can even technically, like you might not realize it, but you do proofs in everyday life. Like if you're trying to convince your parents to buy you something, or let you go on a trip, or let you go somewhere with your friends, you're kind of doing just that. You kind of provide them with facts or a logical statement of like, well, this is one thing that I could do. Then a second step, and a third one, potentially if you're trying to convince them of something, or when you're talking to your friends about something, whatever it is. So we do it a lot. We just don't do it so systematically or organized, and that's what we're about to show is a 2-column proof, because there'll be 2 columns to it, kind of showing us all of those things. Okay, so the other 2 types of like vocabulary words we need to know are postulates, or theorems, or let's say postulates / axioms. Mostly you're going to see the word postulates. Sometimes we'll see axioms show up. They won't come up as often, but basically they're rules that are accepted without proof. So like mathematicians decided these postulates or these axioms don't need to be proven. They're just like almost like common sense or something that you just take for granted. One way to show you where this stuff is, if you look on the side here, you'll see different names: property, theorem, definition, or postulate. Axioms don't show up on here really yet, and I don't think we have really any on here. But again, you can go through the whole list to find the different words there. Okay, so we're going to mostly stick today with properties. And again, we don't need to necessarily prove them. You could also add actually properties here. Definitions we don't really add because it's just kind of telling us a formal definition of something. But rules that do need to be proven or that can be proven, those are called theorems. So anytime we come up with a theorem in this class, we could try to prove it. And not necessarily, we don't have to do every single one, but we could if we needed to. All right. So now here are the algebraic properties that we're about to use as we get started. And again, you've used these properties for so long and not maybe realized that that's what you were doing. So an algebraic property, first of all, A, B, and C are just numbers. We're just using letters to represent those same, numbers. So addition property of equality basically says if you have a statement where A is equal to B, like imagine two numbers or a variable and a number set equal to each other. All you would do then is you would then add the same number to both sides. Remember when we balance an equation, you can either add or subtract the same number to both sides of an equation? That's what we're going to do here. We're going to go ahead and add C to the left side and add C to the right side. But here's the tricky part that sometimes students forget. There's no such thing, or we don't call it, sometimes other schools may do this, but in our school at least, we stick with addition property of equality, and that can represent addition and subtraction. Because remember, C could just be a negative number, and you would be then subtracting the same number. So addition and subtraction are both going to fall under addition property of equality. Okay, so just make sure it doesn't matter what C is, if it's positive or negative, but if you're adding the same number or subtracting the same number to both sides, that's going to be addition property of equality. Okay, then imagine what multiplication property is. We're going to go ahead and multiply the same number times both sides of this equation. So A times C and B times C would be equal to each other. But again, C could be a fraction, like 1/3 or 1/2, and that's technically then dividing. So although it only says multiplication property of equality, it includes division as well. Okay, so multiplication and division are included when you're working with the multiplication property of equality. So far, you've kind of had 4 operations done. Adding and subtracting, go with the first property, multiplication and division with the second property. The last property here that kind of goes together with these is something you've probably done all along as well and not realized it needed a special name to it, and that's substitution property of equality. And that means basically whenever you go to substitute or plug a number in or plug a variable in, that's what you're doing with the substitution property. So if A is equal to B, then B can replace A. Right? So anywhere you would see A in the equation, you could replace it with B. And here's an example. If I had, let's say, A plus 2 equals 7, and I knew that A was equal to B, I could replace this A with B, right? So since I know this is true, I could just kind of replace it. So it becomes B plus 2 equals 7. Both things would be the same idea, that since A and B were the same. And finally, one last property, which I'm sure you've heard of a lot, is called the distributive property. And again, this is still a distributive property of equality. You don't have to write the whole thing. We're going to give shorthand for these other 3 as well, because if you look on your yellow packet, notice there's like these little, it's always like a shorter version of it that we can write down, because when we're doing so many proofs, we don't want to write the whole thing down every single time. It gets repetitive. It's a lot to write down. So we're going to look for these like shortcuts when we get started here in a minute. But distributive property, you can just write distributive property. You don't need to put of equality or put it equals or anything, because there's no other one that we're going to do. For addition and multiplication and substitution, we only do it of equality because we're dealing with equal signs, right? On both sides, we're going to balance our equations, or we're plugging into something, so that's why equal signs are involved. So here's distributive property. Remember, that's where you distribute or multiply. So it would be AB plus AC. You would just multiply the A times both those terms. If you need to, you can write right before it or after it that's what I just did, right? Like that with an equals. But really the main idea here is AB plus AC is what that ends up being, because I just did the distributive property. Okay, so now what we're going to do is we are going to solve some equations. Now, if you need, like, depending on how you've shown your work in the past with algebra, some of you may have shown more work than others. Basically, here's where I'm telling you it's okay not to show work. Because we're in geometry now, you don't have to show, like, adding the same number to both sides, multiplying the same number to both sides, because that part you could either do in your head, or you're going to do it off to the side as, like, your scratch work, because the proof itself will not include that, okay? And so here's how we do our first 2-column proof. You start with, it's usually going to be drawn out for you like this, with reasons on the right and statements on the left. And your first step will always say given for the reason, Okay, so either that will be filled in for you, or you'll write it in yourself and write number 1, given, because it's saying what information were you provided with, what were you starting with, and that also is given right here in the problem. So we're going to just kind of rewrite exactly this whole problem to the right here on statements. So again, we're going to number everything to keep it organized so that if for any reason you get off track, and so everything is still numbered and you know what's what. Let's rewrite this whole problem. 2 parentheses 4x minus 3 minus 8 equals 4 plus 2x. So I just rewrote that whole equation out exactly like I see it. Now my goal is, it says prove that x is equal to 3. So they basically want us to do a whole problem here and find out that x is 3. And that's something you should already know how to do because we've done algebraic problems like this before. But let's kind of jog our memory, make sure we know how to do it. So our first step is, when you look at a problem like this, is distributive property, right? We would say, how are we going to kind of move forward to find x? Well, we would distribute. So here's where I write for step 2, distributive property. If you don't want to write the whole property's name, if you look at your yellow or gold sheet right here, the abbreviation is, you can write prop with a little dot instead of property. But you should really write the whole word distributive, just so that we know what you kind of mean by that. So distributive prop is good enough, or property if you want to write it all out. And let's see what you get when you do distributive property. That's what our left side will show. So 2 times 4x is 8x. 2 times negative 3 would be negative 6. Keep the rest the same for right now. So just rewrite minus 8 plus or equals 4 plus 2x. Okay, and then from here, you're going to do step 3. Now, usually if you were to see this problem and say, well, what do I do next? You would try to combine like terms, like the negative 6 and the negative 8. You would not move forward until that's usually added together. Now, sometimes with algebra, though, I know it's okay to do certain steps. If, like, someone might do it one way and I might do it another way. That's okay, but here it makes the most sense to kind of get that combined first and then deal with the x's on both sides and the numbers on both sides to try to get rid of them being on both sides. So let's first get rid of the negative 6 and negative 8. We know that negative 6 and negative 8 would be a negative 14. So let's go ahead and rewrite that left side with 8x minus 14 equals 4 plus 2x. But here's what's kind of tricky. For a reason for that, if you look through our packet, because again, anything that's in this column for reasons has to come from this packet. Okay, and so again, I don't expect you to memorize it all. Remember, you can use this on every quiz and test. So if I keep looking through it, there's nothing there. And so really, whenever we go to combine like terms, we have to do distributive property. It's a form of distributive property, even though I know it doesn't look like the traditional distributive property like we just did. Anytime you combine like terms, you're going to use that as your reason. It's the same idea as, and sometimes you could put in parentheses to remind you that really I combined like terms. Sometimes people will use the word simplify, but again, I want to stick with what we have in our packet, so we're not like reinventing new things to add to the reasons. So although it's combining like terms, we are still using distributive property because technically it's like almost like distributing a 1 and then you're combining the two terms. That's the idea here. Okay, so here's a common mistake though. We cannot use the addition property of equality because we are not adding the same number to both sides. That's only used when you're adding the same number to both sides to balance out, to get rid of something. We didn't do that. We just added terms on one side. And so that's why we use distributive property. All right, now on to step 4. Here's where sometimes students can have different answers because I personally will try to get the variables to one side first, which is probably how you learned it back in 8th grade or 7th grade or whenever you learned it. And for some people, they might choose to get the numbers on the same side. It really doesn't matter. You can pick, but I'm going to go ahead and say, how am I going to get my variables on the same side? I would want to subtract the 2x to the other side. And so this right here would be called addition prop equality. That's like the shorthand. If you don't want to write out all of those words, you can just use a plus sign, prop, and an equal sign. Okay? Now step 4, though, here's where I mentioned you don't want to show work. Whatever work you want to do, you either do it in your head or you can write it off to the side if you want to, where you could show like, okay, I need to subtract, whoops, that's 4, plus 2x. I need to subtract 2x like this. The answer you get after you've subtracted it is what goes on the line. Okay, so 8x minus 2x is 6x. I still have that 14, and I still have the 4, but now, of course, the 2x is moved. So I'm getting closer and closer to getting x all by itself. This is where I'm at so far. Okay, then we want to get rid of that negative 14 because, again, we're trying to isolate the x. So, again, we're doing another addition property of equality because we're adding 14. So, again, if you need to show work for yourself, do it outside of the two-column proof. Do it somewhere else or just do it in your head, right? Adding 14 here would be 6x equals 18. Okay, so if you do need the work, here it is off to the side, you would add 14. Okay, and that's how we get 6x equals 18, which goes on the line. And now we're almost done here. The last step, we need to divide. But remember, there's no such thing as division property of equality. You can only use the ones we have right here. So that would be multiplication property. And so if you don't want to spell out the word multiplication, use the little dot. Multiplication prop equals, and that would be our last step, because as soon as you get the answer, right, and if you, again, need work here, divide by 6. As soon as you get to x equals 3, remember that was what was asked to be proved, and we just did in 6 steps. Okay, now sometimes proofs vary in the number of steps. Don't ever feel like, oh look, there's a box left over, maybe I did something wrong. Those are just a random number of boxes that I don't want to, say it has to be a certain number. Okay, great. For the rest of the time now, the back page is practice for you guys to try. There's 2 more of the same thing. And then number 2 at the bottom here, there's a student that did work and they did something wrong, so you're trying to figure it out. So take the time to try out number 1 and 2, and I will share these answers before you leave today. All right, so these are the answers for example 1A. We have our given for the first step. Then we had to subtract or move the x's onto the same side, so that's addition property equality. And then number 3, we had to subtract the 8, so again addition property equality, and then finally divided by 7 to get multiplication property of equality. Same idea for the second one, except you have to start with distributive property with the 2h plus 2, and then finish up with more addition property and multiplication property equality. I lost. That's a multiplication right there. All right, and then finally, the last part, the student that was doing their work, the mistake they made was that they called the third step addition property of equality instead of distributive property of equality, which is, remember, the same as combining like terms. You can't use addition property if you're adding on the same side of the problem, like on this side. All right, and that's pretty much it. The answer key for this will show this in more detail too, that's posted. But that's the idea for these proofs.